Today we're going to be looking at rate/start models and lines, which is another component of Algebra 2. So rate and start models use this general equation, which is T equals Rx plus S, where T represents the total amount, R represents the rate or cost for each item, X represents the number of items, and S represents the starting amount. So we can use this equation to solve multiple problems. For example, a taxicab company uses the model above to calculate the cost of the fare, C, in dollars for single riders within a metropolitan area based on the distance traveled, D, in miles. What is the meaning of the value 6 in this equation? Okay, well, we can compare the equation they give versus the equation that we can use for these types of problems. So if you look, they're basically in the same format, where the total amount equals the rate times the number of miles in this case, plus a starting amount. So C represents T, 0.25 is R, D is replaced with X, therefore 6 is replaced with S. So 6 represents the starting amount. So if you look at the answers they gave you, the answer would be D, because the taxicab company charges a minimum $6 fee for single riders, regardless of the distance traveled, which is another way of saying the starting amount. Let's look at another problem. This problem says, every month, Blair buys 1 bag of cat food for her 3 cats. The amount of food that she has left in the bag at the end of each day can be estimated with the equation G equals 1,810 minus 57D, where G represents the amount in grams of food left, and D is the number of days since she bought the bag. What is the meaning of the value 1,810 in this equation? Well, this equation is essentially the same as the equation before and also our general equation. It just uses a minus sign. But don't get tripped up by that, because we can also rewrite the equation to be a plus sign. So to do that, I would do G equals 1,810 plus negative 57D. And now this equation looks exactly like our general equation, where G is replaced with T, and the negative 57 is our R, our rate. D is X, so 1,810 is S, the starting amount. So if we look at our answer choices, the answer is B, which says Blair's bag of cat food initially contains 1,810 grams of cat food, so the starting amount. The next topic is lines, and 4 things to think about regarding lines on the SAT is slope, slope-intercept form, parallel and perpendicular lines, and point-slope form. So let's look at slope first. Slope is defined as the change in y, which is represented by this triangle, which is delta, or change. Change in y over change in x, or rise over run. And we can solve this using the equation y2 minus y1 over x2 minus x1, where x1, y1 is one coordinate pair on the line, and x2, y2 is another coordinate pair on that line. So let's look at an example. What is the slope of a line containing the points 3, 4, and 8, 14? Well, 3 is x1, 4 is y1, 8 is x2, and 14 is y2. Okay, so we can solve using this equation. So y2 is 14 minus y1, which is 4, over x2, which is 8, and x1, which is 3. And when you solve this out, you get 10 over 5, which can be simplified to 2. So 2 is the slope of the line. When we're looking at slope, we also look at whether it is a positive or negative slope. And a positive slope moves up and to the right of a graph, and a negative slope moves down and to the right of a graph. And it's important to remember that when you're looking at whether a slope is positive or negative, you always look at how the line is moving to the right. So whether it moves up or down when you're looking at it to the right. And slope-intercept form is a form of the equation of a line. So there's also point-slope form, but we're looking at slope-intercept form at this moment, which is y equals mx plus b. And they're both representing the same line, just in different forms. So for this one, m represents the slope of the line, and b represents the y-intercept of the line, or where the line crosses the y-axis. So just as a refresher, this is your line. The y-intercept for this line would be right here, because that's where the line crosses the y-intercept, or the y-axis. So what is the slope of the line y equals 7x plus 6? Well, looking at y equals mx plus b, the slope-intercept form, we can tell that 6 is b, so 7 is m, or the slope. Parallel lines are lines that have the same slope, m, but different y-intercepts. So if you were to draw this out, these lines are parallel because they have the same slope, but they have different y-intercepts. Because this line has a y-intercept up here, and this line has a y-intercept down here. Okay, so then what is the slope of a line parallel to y equals negative 3x plus 1? Well, we just talked about how parallel lines have the same slope. So a line parallel to this one would have the same slope, which is negative 3. Perpendicular lines are lines that have slopes that are negative reciprocals of each other. So to draw this out, if you had one line like this, a perpendicular line would come down like this. And their slopes are negative reciprocals of each other, which means it is the number flipped and has the opposite sign. So let's look at an example. What is the slope of a line perpendicular to y equals negative 3x plus 1? Well, I think it's easier to represent the slope in a fraction, even though it's a whole number. So negative 3 over 1. To find the negative reciprocal, we flip the fraction around. So the denominator comes on top to the numerator, and the numerator comes down to the denominator. So in this case, the negative reciprocal of negative 3 would be positive 1/3, because the 1 from the denominator went to the numerator, and the 3 from the numerator went to the denominator. And it's positive because it is the opposite sign of what it is originally. And since it was originally a negative sign, the negative reciprocal would have to have a positive sign. But if it was originally positive, the negative reciprocal would be negative. Point-slope form is another form of an equation of a line. So this one has y minus y1 equals m times x minus x1, where m still represents the slope of the line, but x1, y1 represents any point on the line. So this form is useful when you're given a coordinate pair. So for example, it says, find the equation of the straight line that has a slope of m and passes through the point -1, -6. Okay, so using the point-slope form, we can write y minus, and it gives us y1, which is -6. So y minus -6 equals, they give us m, which is 4, x, and then they give us x1, which is -1. And we can clean this up. So y plus 6, because a negative, 2 negatives is a positive, or subtracting a negative is addition, and the same thing here. 2 negatives is a positive. Okay. We can leave it like this, but we can also further simplify. So y plus 6 equals 4x plus 4. And what I just did is I multiplied the 4 out, distributed it. So it's 4 times x plus 1, or 4x plus 4. And then I'm going to bring the 6 onto the other side to get y equals 4x minus 2. And if you notice here, we have turned an equation from point-slope form into slope-intercept form. So they're interchangeable. Okay, let's look at another practice problem. It says, rewrite the following in slope-intercept form. Y minus 3x equals 4. Well, slope-intercept form is y equals mx plus b. So we just want the y to be by itself on a side. So we can just move the 3x onto the other side. To get y equals 3x plus 4. Okay. The next problem says rewrite the following in slope-intercept form. X equals 4 times y minus 2. Okay, same thing here. We can start by first distributing and simplify. So x equals 4y minus 8, because 4 times 2 is 8. And then we can get y onto one side by moving the 8 to the other side. So x plus 8 equals 4y. And then we want y to be by itself, so we can divide everything by 4. Which gives us 1/4 x plus 8/4, which is 2, equals y, which is the same thing as y equals 1/4. And I chose to write 1/4, but you can also write x over 4. So 1/4 x plus 2. Okay, the next problem says, the graph of the linear function g passes through points 0, a and b, 0 in the xy plane. If a over b equals 1 and b does not equal 0, which of the following is true about the slope of the graph of g? Okay, this problem seems like a lot at first because there are a lot of words and a lot of complicated components, but we can break it down one by one and see that this problem is actually not very hard. Okay, so first let's look at the points. So they didn't give us numbers, they gave us 0, a and b, 0. So the x-intercept and the y-intercept, right? Okay, but it also says that a over b equals 1. This is just a fancy way of saying that a and b are the same number, because if you divide the same number by itself, you get 1. Okay, so the easiest way to solve this question is to just pick a number for a and b, because they're the same. So let's pick 1. A equals b, which equals 1. So the points you have are 0, 1, and 1, 0. And you can solve this problem in 2 ways from here. You can draw out a graph and see what kind of slope occurs from these 2 points, or you can actually solve for slope, what we did before, which is y2 minus y1 over x2 minus x1. So y2 is 0 minus y1, which is 1, over x2, which is 1, minus x1, which is 0. And this gives you negative 1 over 1. So your slope would be negative, which is choice B. And if you chose to draw this out, you would have 0, 1, so a point right here, or 0, 1 is here, I'm sorry, and 1, 0, which is here. And if you connect these 2 points, you would see that the line is going down as we look to the right, which we talked about before is negative.